Okay, now we have just discussed that SI unit of charge is coulomb, right? So charge is denoted in coulombs. So how much or how many number of electrons will be in 1 coulomb of charge? See, to understand this, let me take you back to that example where I told you about free electrons which actually carry the charge or which actually constitute the current. These are free atoms or molecules associated or the particles which make up the whole conductor, and these red dots, these are the free electrons which actually move. These are the electrons called conduction electrons which actually constitute the current, and they flow in a direction which is provided by the external battery or external source or called cell. Now, what would be the charge flowing in this much thing, this much drawing? Okay, see, charge, as we have already discussed, is made up of, or it is built by all of these free electrons. So that means total charge would be some number of electrons, right? For that, we need to know what is the charge on one electron. The charge on one electron is given by 1.6 into 10 raised to power minus 19 coulombs. This is the value of charge on one electron. This is one electron, right? So to find total charge or total number of electrons which are present in 1 coulomb of charge, what we are going to do, this is 1 coulombs, n number I don't know, times electronic charge, 1.6 into 10 raised to power minus 19. So instead of this question mark, I'll be replacing it with n right now. So I have to find the value of n. So n comes out to be 1 upon 1.6 into 10 raised to power minus 19 coulombs. Or see, how can we solve it out? 10 raised to power 19 goes up and becomes 10 raised to power plus 19. I am left with 1 upon 1.6. I am not going to disturb this 10 raised to power 19. All I am going to do is I'll deal with 1 upon 1.6 into 10 raised to power 19. This becomes this decimal becomes 16 upon 10. So instead of writing it like 16 upon 10, I can write it as, I can write the 10 on the numerator side, right? So this goes like this way, times 10 raised to power 19. So cancel it out by 2, I'll get 5 and 8, right? So I have to divide 5 with 8. So I'll get 8 into 6 is 48. So 0.6, 8 into 6 is 48. Then I'm left with remainder 2. So 8 into 2 is 16. Then 5. So 0.625 into 10 raised to power 19, or I can write it as 6.25 into 10 raised to power 18, because I have utilized 110. 10 raised to power 19 means 10 into 10 into 10 into 10, 19 times. This is what 10 raised to power 19 means. So I have utilized 110. So this 0.625 comes out to be 6.25. So I am left with 18 times 10. So that is why I have written it as 6.25 into 10 raised to power 18. So what should be the unit I should write here? I won't be writing any unit. That is because Q is N times E. This is called quantization of charge. I'll explain the meaning of quantization in a while. But I was telling you about why I'm not going to write any units here, because this Q is equal to NE. This represents that total charge is integral multiple of electronic charge. Integral multiple means I cannot break out this electron or this electron. I cannot break these electrons and take half of the electron. So that means the total charge which is accumulated or which is responsible in any conductor will always be some number, some particular integral number or integer number times the charge on each electron. That is how total charge will be made. So total charge on any conductor is integral multiple of electronic charge. This is called quantization. I would like you not to remember this word because it is not concerned with your syllabus. I'm just giving you some additional information as well. Quantization means, the word quantization, as I've already stated, is quantization means finding the unit part which can constitute the whole matter. For example, if I have to quantize this wall is made up of bricks, right? So if I quantize this wall, I'll get 1 brick. So if I place 500 bricks one above another, I'll get the complete wall. So this is something what quantization means. So the n is representing the number of electrons, and that is why this is representing these many electrons will constitute 1 coulomb. So I don't have to write any units here.